Why do black holes only have three properties? Have you ever wondered why black holes, those mysterious giants of the universe, seem to have only three properties? It's a fascinating topic that dives into the heart of physics and astronomy. Let's break it down together. Black holes are described by three main characteristics: mass, electric charge, and angular momentum, which is also known as spin. This idea comes from something called the no-hair theorem. This theorem tells us that when a black hole forms, all other information about the matter that created it is lost to anyone outside. Only these three properties remain visible. First, let's talk about mass. Mass is the total amount of matter energy in a black hole. This mass determines how strong the black hole's gravitational pull is and the size of its event horizon. The event horizon is the boundary around a black hole beyond which nothing can escape. Next is electric charge. A black hole can have an electric charge, which can be either positive or negative. However, in nature, most black holes are thought to have almost no charge. This is because opposite charges tend to cancel each other out quickly, leaving black holes mostly neutral. The third property is angular momentum, or spin. Black holes can rotate, and this spin affects the shape of their event horizon and the space around them. This leads to interesting effects like frame dragging, where space itself gets twisted near the black hole. Now, why do black holes only have these three properties? It all comes down to the laws of physics and Albert Einstein's theory of general relativity. When a massive star collapses to form a black hole, all details about the star's structure or composition vanish behind the event horizon. The gravitational field outside the event horizon can be completely described by just mass, charge, and spin. Gravity plays a big role here. The intense gravitational force of a black hole pulls everything into a very compact area, smoothing out any irregularities. This means that any complex features of the original star are erased. Additionally, anything that falls into a black hole cannot affect the outside universe. Therefore, all the details about that matter do not show up as observable properties. Mathematical solutions to Einstein's equations also support this. The known solutions for black holes show that only mass, charge, and spin appear in the external gravitational and electromagnetic fields. In simpler terms, think of a black hole's identity card. It only lists its weight, electric charge, and how fast it spins. Everything else is hidden away and cannot be accessed. Understanding these three properties helps scientists predict how black holes interact with other objects in space. This includes how they pull in matter, emit energy, or merge with other black holes. It also opens the door to fundamental questions about gravity, quantum mechanics, and the nature of space and time. So, the next time you gaze up at the night sky, remember that black holes, despite their complexity, can be understood through just three simple properties.